This is the story of a winter storm so threatening that 7 states declared emergencies before a single flake of snow touched the ground. January 2026 brought what meteorologists called the most widespread winter storm the country had seen in a while, a system stretching 2,000 miles from the Texas and New Mexico border to the northeast coast. More than 175 million Americans across 35 states stood in its path. 3 separate dangers converged into one event: heavy snow, dangerous ice accumulation, and an Arctic cold outbreak that prompted governors from Texas to West Virginia to activate emergency resources days before anything arrived. The question worth examining here is not simply what this storm brought, but why officials felt compelled to act with such urgency before it even began. The answer lies in atmospheric mechanics, geographic realities, recent traumatic history, and the hard lessons learned from past disasters. This is the complete story of Winter Storm Fern. Part 1. The Atmospheric Engine. Understanding why emergency declarations came so early requires understanding what meteorologists saw forming in the atmosphere weeks before the first winter storm watch went out. Mid-January 2026 brought troubling news from high above the Arctic Circle, where NOAA extended range guidance detected a sudden stratospheric warming event disrupting the polar vortex. That massive circulation of cold air normally stays locked over the Arctic during winter months, but polar vortex expert Dr. Judah Cohen documented what he described as a stretched vortex configuration. Instead of remaining as a single coherent mass of cold air over the pole, the vortex had split into 2 centers, one positioned over the Barents Kara Seas and another over Baffin Bay. What meteorologists call a wave reflection pattern had formed, and its consequence would deliver Arctic air southward into the region east of the Rocky Mountains. This was not a theoretical concern. A powerful high-pressure system measuring 1,052 millibars was pushing into North Dakota at that very moment. High-pressure systems rotate clockwise in the northern hemisphere, so this massive dome of dense, cold air would act like a pump, funneling extremely cold Arctic air deep into the southern United States. Cold air alone does not create a winter storm, though. Moisture makes the difference. The National Weather Service Weather Prediction Center issued a forecast discussion on January 21, 2026, describing the other half of this atmospheric equation. A broad upper trough off Baja California would work in tandem with a ridge axis near Mexico to direct what they called a rich plume of tropical East Pacific moisture into the southern Rockies and plains. Forecasters described a collision course. Extremely cold, dense Arctic air pushing south would meet warm, moisture-laden air streaming north from the Gulf of Mexico, and where these 2 air masses met, precipitation would fall. The temperature at which that precipitation fell would determine whether communities received snow, sleet, freezing rain, or a dangerous combination of all 3. This atmospheric setup produced a weather system that the National Weather Service Weather Prediction Center officially classified as a winter storm with potentially historic impacts. The Weather Channel designated it Winter Storm Fern. Part 2. The Geographic Scope. When meteorologists mapped the potential impact zone for this system, the scale became immediately apparent, with the storm's path stretching from the southern plains and southwest through the deep south, the Tennessee Valley, the southeast, the mid-Atlantic, and potentially into the northeast. More than 35 states fell within its potential influence. The southern plains faced the initial impact across Texas, Oklahoma, Kansas, and New Mexico. Arkansas, Louisiana, Mississippi, Tennessee, Kentucky, and Missouri came next in the Mid-South and Tennessee Valley. Alabama, Georgia, North Carolina, and South Carolina followed in the southeast. Virginia, West Virginia, Maryland, Delaware, and Washington, D.C. made up the Mid-Atlantic zone. Pennsylvania, New Jersey, New York, Connecticut, and Massachusetts potentially rounded out the Northeast. This was not a regional event. This was continental. Consider the major metropolitan areas directly in the storm's path. Dallas-Fort Worth with its metro population of 8 million people, Atlanta with 6 million, Washington, D.C. with 6.4 million, Philadelphia with 6.2 million. And if the storm intensified as it moved offshore, New York City, with a metro population of 20 million people, would take a direct hit. Oklahoma City, Nashville, Memphis, Charlotte, Raleigh, Baltimore, and Richmond all faced direct impacts as well. Between 49 and 70 million people were already under winter storm watches, stretching from New Mexico to Tennessee by January 21st and 22nd. AccuWeather reported that more than 150 million people in the southern and eastern United States would be affected, and Fox Weather placed the figure even higher, at more than 175 million, approximately 55% of the contiguous US population. These numbers explain the first reason for early emergency declarations: sheer scale. When a weather event threatens more than half the nation's population across more than 35 states, the logistics of preparation, response, and potential recovery require advance mobilization that simply cannot happen in real time. Crews need positioning, equipment needs staging, supply chains need activating, coordination between state and federal agencies needs to begin well before impact. Scale alone doesn't fully explain the urgency, though. For that, we need to examine what this storm was actually bringing. Part 3. The snow threat. Snowfall forecasts for Winter Storm Fern painted a picture of serious accumulation across a wide corridor from the southern plains to the mid-Atlantic. Oklahoma City faced the prospect of 8 to 14 inches of snow, and according to Fox Weather, this would potentially rank among the city's top 5 largest snow events in recorded history. That amount of accumulation would be genuinely disruptive for a city that does not regularly experience heavy snowfall. Little Rock, Arkansas, expected 6 to 12 inches. While Nashville and Memphis would see heavy accumulations that forecasters were still refining as the storm approached. The Winston-Salem, North Carolina corridor emerged as one of the heaviest snow targets, with forecasts of 12 or more inches, a serious amount for the Piedmont region. Washington, D.C. and the Mid-Atlantic were forecast for heavy snow, with growing confidence that this could be the most serious snowstorm for the region in years. The nation's capital had not experienced a truly major snowstorm recently, and forecasters saw this system as having that potential. The Northeast faced considerable uncertainty, but the potential was substantial. If the storm intensified as it moved offshore through a process meteorologists call bomb genesis, New York City and Philadelphia could see 12 or more inches. Lake effect enhancement off Lake Ontario could push totals around Syracuse to 28 inches. These snowfall amounts are manageable for communities with adequate snow removal equipment and preparation time, and northern cities regularly handle accumulations of this magnitude. But here is the thing. This storm was not just bringing snow to areas accustomed to dealing with winter weather. Snow was heading for the southern plains, the mid-south and the southeast, regions where snow removal infrastructure is limited and populations are less experienced with driving and living in heavy snow conditions. And for many communities, snow was not even the primary threat. Part 4. The ice threat. This is where the emergency declarations begin to make complete sense. Ice storms rank among the most dangerous and destructive weather events in the United States. They occur when precipitation falls through a temperature profile that allows rain to remain liquid until it contacts surfaces at or below freezing and then freezes on contact. The result is a coating of ice that accumulates on roads, power lines, trees, and structures. Ice forecasts for Winter Storm Fern identified 2 primary danger zones. The first stretched from East Texas through southern Arkansas, a corridor that forecasters called the bullseye for the most serious ice accretion, with accumulations of 0.2 to 0.5 of an inch forecast, enough to make roads impassable and bring down power lines. The second ice threat zone ran from Atlanta through Augusta, Georgia, then through Columbia, South Carolina, and into Raleigh, North Carolina, where up to 0.5 inch of dangerous ice accretion could fall. Duke Energy spokesperson Caroline Fountain explained why these numbers prompted emergency declarations. She said that when people think of snow, it takes up to 6 inches to impact tree limbs, enough to bring them down onto power lines and cause outages. It only takes 1/4 of an inch of ice to do that same thing. 1/4 inch of ice. That's all it takes to start bringing down power lines and snapping tree limbs, and the forecasts were calling for double that amount in some areas. Dallas-Fort Worth faced a particularly hazardous situation, with hazardous ice beginning Friday and precipitation transitioning between snow, sleet, and freezing rain, depending on temperature fluctuations. This variability made preparation more difficult because road treatment strategies differ for each precipitation type. The critical snow-ice transition line, the boundary separating areas that would receive primarily snow from those that would receive primarily ice, generally followed the Interstate 40 corridor. Communities north of that line could expect snow, while communities south of it faced ice. But here is what made forecasters particularly concerned. Any northward shift in the storm track would push ice into areas currently forecast for snow. A shift of just 50 to 100 miles would dramatically alter impacts for millions of people, meaning communities preparing for snow might instead receive ice, having prepared for the wrong threat entirely. The National Weather Service explicitly acknowledged this uncertainty, stating that forecasters were confident in their predictions of an impactful and prolonged winter storm, but that specific details on exactly where the storm would hit and how much precipitation would fall may change. This uncertainty itself was part of the reason for early emergency declarations. When you know a dangerous event is coming but cannot be certain exactly where the worst impacts will fall, the prudent response is to prepare a wider area for the worst-case scenario. Precipitation, whether snow or ice, was only one component of this storm system. 2 other factors compounded the danger substantially. The northern plains and Midwest faced sustained winds of 35 miles per hour or greater, with gusts reaching 40 to 60 miles per hour. Combined with heavy snowfall, these winds would create blizzard conditions with whiteout visibility. Blizzard warnings covered a corridor from South Dakota through Minnesota and Iowa, where conditions would meet the formal blizzard criteria: wind gusts of 35 miles per hour or greater, combined with visibility reduced to 1/4 mile for 3 or more hours. These are conditions in which travel becomes not just difficult, but genuinely life-threatening. Drivers caught in whiteout conditions can become disoriented and stranded, while emergency responders struggle to reach those in need. Wind-driven snow penetrates gaps in buildings and vehicles that would normally provide adequate shelter. And that's when things got worse. The cold that followed the storm posed perhaps an even greater threat than the storm itself. Temperature drops would be dramatic. Texas minimum temperatures were forecast to fall to around 9 to 10 degrees Fahrenheit. The upper Midwest would see air temperatures dip to -3 to -10 degrees Fahrenheit, while the northern plains experienced below zero conditions. Wind chill values reached life-threatening levels. -40 to -50 degrees Fahrenheit across the northern plains can cause frostbite on exposed skin in as little as 5 to 10 minutes. Texas and Gulf Coast states faced wind chills in the single digits to -10 degrees Fahrenheit, conditions these regions rarely experience and for which many residents are unprepared. More than 50 record low temperatures were possible from Sunday through Tuesday, according to the National Weather Service, concentrated in Texas and southern states. Dallas faced a particularly concerning forecast: 48 to 100 or more hours below freezing from Friday through early next week. This extended period of sub-freezing temperatures meant that whatever ice accumulated would not melt, whatever snow fell would remain, roads treated with chemicals would refreeze, and most critically, power restoration efforts would be severely hampered. This combination, ice bringing down power lines followed by days of extreme cold, preventing crews from safely working and preventing natural melting, is what turns a winter storm into a potential disaster. Homes without power also lack heat. Pipes freeze and burst in extreme cold. The elderly, The very young and those with medical conditions face genuine danger. Kurt van Spiebroek of the National Weather Service summarized the situation, saying that by Sunday, the whole state will definitely be experiencing well below normal temperatures and dangerous wind chills. He added that 2/3 to 3/4 of the state would have some pretty dangerous winter driving conditions. AccuWeather Chief Meteorologist Jonathan Porter issued a stark warning that potentially hundreds of thousands of people may go without electricity and heat for days. For Texas specifically, and to a lesser extent for the broader region, these forecasts arrived with a traumatic recent memory attached. February 2021 brought Winter Storm Uri to Texas with catastrophic results. More than 246 people died in Texas alone. Damages exceeded $195 billion. The Texas electrical grid collapsed under demand it could not meet, leaving millions without power during extreme cold while pipes froze and burst across the state. People died in their homes from hypothermia, and others died from carbon monoxide poisoning while trying to heat their homes with generators, cars, or other improvised methods. The 2021 disaster exposed fundamental vulnerabilities in Texas infrastructure and emergency preparedness, and it created a political and psychological imperative. Texas could not afford to be caught unprepared for a similar event. National Weather Service meteorologists were explicit in comparing the two storms. Alison Prater, a meteorologist at the National Weather Service in Fort Worth, drew the direct comparison by noting that in 2021, the minimum temperature was -2 degrees, while in our current forecast, the minimum temperature is only going to be around 9 to 10 degrees. That difference of more than 10 degrees warmer at the coldest point matters. The 2026 storm would not match the severity of 2021's Winter Storm Uri, and National Weather Service meteorologists stated this explicitly. Key differences extended beyond temperature. Dallas faced an estimated from 48 to 100 or more hours below freezing in 2026, compared to 139 hours below freezing in 2021. The 2026 storm would last approximately 4 days, while the 2021 event brought approximately 1 week of extreme conditions. Meteorologist Prater emphasized that while temperatures would be warmer than 2021, it would still be dangerously cold, and she urged people to be prepared. This comparison context helps explain why Texas Governor Greg Abbott issued his early emergency declaration. On January the 20th, 2026, days before the storm's arrival, Abbott activated state emergency response resources and directed the Texas Division of Emergency Management to prepare. His statement reflected both the current threat and the lessons of 2021. Based on current forecasts, the state of Texas is acting to ensure Texans have the resources they need before severe winter weather impacts communities across Texas. It is crucial that Texans remain weather aware, check drivetexas.org before traveling, and heed the guidance of state and local officials. The proactive stance represented a deliberate contrast to 2021, when many critics argued the state's response was too slow and too disorganized. Each of the 7 state emergency declarations reveals something about official concerns. Texas Governor Greg Abbott, a Republican, activated state emergency response resources on January 20, 2026. Texas faced the full combination of threats: ice in the Dallas-Fort Worth area, extreme cold statewide, and the lingering institutional memory of 2021. Abbott's declaration focused on ensuring Texans had the resources they needed before severe winter weather impacted communities. North Carolina Governor Josh Stein, a Democrat, declared a state of emergency on January the 21st, 2026. He said a winter storm is approaching, and now is the time to prepare. He urged all North Carolinians to stay home and off the roads this weekend unless absolutely necessary, so first responders can do their jobs safely and effectively. North Carolina faced serious snow in its western and Piedmont regions, with the Winston-Salem corridor potentially receiving 12 or more inches, while the Raleigh area faced ice. Governor Stein's emphasis on keeping roads clear for first responders reflected the reality that emergency response becomes exponentially more difficult when roads are clogged with stranded or crashed vehicles. Georgia Governor Brian Kemp, a Republican, declared a state of emergency that would remain in effect through January 28, 2026, authorizing up to 250 Georgia National Guard troops, a serious mobilization for a weather event. His public statement laid out specific preparation steps: secure food, fill up on gas, and ensure you are prepared for any potential loss of power. He asked Georgians to help emergency workers do their jobs by limiting travel as much as possible. Atlanta, the state's major population center with 6 million people, fell directly in the icy threat corridor, where up to half an inch of ice accumulation could occur. The hilly terrain that makes Atlanta particularly vulnerable to icy conditions justified the extensive preparation. South Carolina Governor Henry McMaster, a Republican, issued Executive Order 2026-02 declaring a state of emergency. Like North Carolina and Georgia, South Carolina faced the ice threat as it moved up the eastern seaboard, and Columbia, the state capital, was identified in forecasts as being in the ice accumulation zone. Virginia Governor Glenn Youngkin, a Republican, declared a state of emergency for the Commonwealth. Virginia faced both the ice threat in its southern portions and heavy snow in the northern part of the state near Washington, D.C., meaning the state's geographic diversity would expose it to nearly the full range of the storm's impacts. Maryland Governor Wes Moore, a Democrat, issued a state of preparedness declaration. Maryland, particularly the Baltimore-Washington corridor, was in the path of what forecasters believed could be the most serious snowstorm for the region in years. The declaration allowed for pre-positioning of resources and coordination between state and local agencies. West Virginia Governor Patrick Morrisey, a Republican, declared preparedness for all 55 of the state's counties. West Virginia's mountainous terrain makes it particularly vulnerable to winter storms, and the statewide declaration reflected the expectation that impacts would be felt throughout the state rather than concentrated in one region. 7 states, 4 Republicans and 3 Democrats. Emergency declarations were issued 2 to 4 days before the storm's arrival. The bipartisan nature of the response underscores that this was not a political calculation, but a response to genuine forecasted danger. The emergency declarations from governors were informed by increasingly urgent warnings from National Weather Service meteorologists across the affected region. Charles Dalton, meteorologist at the National Weather Service office in Morristown, Tennessee, focused on the icy danger and its cascading effects. He said this brings the possibility of power outages, downed trees, and very hazardous travel. Travel impacts, and perhaps some power outages, are going to be the big ones, which is problematic because behind the system, very cold air will move in. Whatever follows this weekend is likely going to stick with us for a few days into the early part of next week. Dalton identified the compounding nature of the threat. Ice causes damage, cold prevents recovery, and the two together create an extended crisis. The National Weather Service, Morristown office serves the Tennessee Valley region. That area would see the storm transition from its initial development phase to its mature phase, bringing both serious snow and ice depending on elevation and exact track. Allison Prater of the National Weather Service office in Fort Worth, Texas, acknowledged the comparison to 2021 while emphasizing the current danger. She said simply that we want people to be prepared. The Weather Prediction Center's January 21st forecast discussion described the atmospheric setup in technical but revealing language, noting the rich plume of tropical East Pacific moisture that would collide with Arctic air. This was not speculative, because forecasters were watching it develop in real time on satellite imagery and in atmospheric models. Jason Furtado, Associate Professor of Meteorology at the University of Oklahoma, provided perhaps the most comprehensive summary, characterizing this as the most widespread winter storm the country has seen in a while also emphasizing the complexity. He stressed that it was not just the precipitation, it was the extreme cold coming in behind it as well. That framing, that the storm was not just about snow or ice, but about the combination of precipitation and extreme cold, informed the scope of emergency preparations. The 2021 Texas grid collapse prompted substantial changes to the state's electrical infrastructure, and those changes were about to be tested. ERCOT, the Electric Reliability Council of Texas, which manages the state's electrical grid, issued a weather watch for Saturday through Tuesday with a cautiously optimistic assessment. Based on expected weather conditions, ERCOT anticipated there would be sufficient generation to meet demand this winter, a sign of growing confidence. The basis for that confidence included substantial additions to grid capacity since 2021. Matthew Bombs, executive director of the Texas Advanced Energy Business Alliance, described what he called a gigantic change. He said that during Winter Storm Uri, Texas did not really have battery storage on the grid. Now there are thousands of megawatts of batteries, and that is a huge asset when a winter event threatens demand. This expanded battery storage matters in multiple ways. Battery storage provides power during peak demand periods, it smooths stress on generation facilities, and it offers backup when generation facilities experience problems. Thousands of megawatts of this capacity represent a meaningful improvement in grid resilience. Individual utilities were also mobilizing. Oncor, which serves West, Central, and North Texas, including the Dallas-Fort Worth area, activated its storm readiness plan. That included inventory and equipment mobilization, expanded crews, and vegetation management to trim trees near power lines that might otherwise break and cause outages during ice accumulation. Oncor meteorologist Katie Blake acknowledged the anxiety winter storms create while emphasizing preparation. She said, "We recognize the worry that comes with winter storms. Oncor has prepared for winter weather, and our field teams have decades of experience safely restoring power in freezing temperatures." Centerpoint Energy, serving the Houston area, reported completing winterization efforts, including equipment upgrades, stronger poles, and selective undergrounding of power lines. Vice President of Distribution Operations, John Cornelius Jr. said some weather could potentially cause outages, but those outages are expected to be minimized. Centerpoint is prepared, coordinated, and ready. The language from utilities was notably more confident than before 2021 because they had invested in improvements, tested their systems, and believed they were ready, or at least readier than before. Forecasters maintained caution. Jonathan Porter, chief meteorologist at AccuWeather, warned that potentially hundreds of thousands of people could go without electricity and heat for days. That risk was not eliminated by grid improvements because ice on power lines can still bring down power lines, regardless of how robust the generation capacity behind them may be. The improvements since 2021 addressed generation failures where power plants went offline during extreme cold. They did less to address distribution failures where power lines come down under the weight of ice. Both failure modes lead to the same result: people without power. The scale of this storm's impact on travel became apparent in the pre-storm preparations by airlines, railroads, and local authorities. Airlines began issuing travel waivers days before the storm's arrival, a practice that allows passengers to rebook without fees when serious weather disruptions are expected. American Airlines issued alerts for Dallas-Fort Worth, Dallas-Love Field, Austin, San Antonio, Houston, and El Paso. Dallas-Fort Worth International Airport serves as one of American Airlines' primary hubs, meaning disruptions there would ripple through the carrier's entire network. Delta Airlines posted weather advisories through January 25th covering the southern plains and southeast, with its Atlanta hub directly threatened by ice. That is a particularly concerning scenario because Atlanta serves as the connection point for a huge percentage of domestic flights. Southwest Airlines issued advisories for January 23rd through January 26th, while United Airlines, Frontier Airlines, and JetBlue Airways all posted similar travel waivers. AccuWeather warned that thousands of flights could be delayed or cancelled, with some airports potentially forced to close temporarily during serious ice buildup. In response, airports prepared their de-icing operations. Dallas-Fort Worth International Airport assembled 875 tons of sand and 169,000 gallons of liquid dicer. Dallas Love Field stockpiled 44,000 gallons of liquid dicer, 156,000 pounds of solid dicer, and 4 snowplows to clear its 13.8 million square feet of runways and taxiways. These numbers give a sense of the industrial scale of winter weather preparation at major airports, because keeping runways and taxiways clear of ice and snow requires continuous operations with heavy equipment and massive quantities of de-icing materials. Amtrak took a precautionary approach and cancelled multiple routes. The Empire Builder, which runs from Chicago to Seattle and Portland, the City of New Orleans, which runs from Chicago to New Orleans, and the Texas Eagle, which runs from Chicago to San Antonio with connections to Los Angeles, were all cancelled. These cancellations extended through January 24th, and Amtrak said it acted out of an abundance of caution. It offered rebooking and refunds without penalties. Rail travel is particularly vulnerable to winter weather because trains cannot simply reroute around problem areas the way aircraft sometimes can. Ice on tracks, switches frozen in position, and downed power lines affecting electrified routes all create hazards that are easier to avoid than to overcome. At the local level, Dallas Police Chief Daniel Como offered guidance that summarized official recommendations across the affected region. If you don't have to go outside, please don't. The storm would unfold over a 4-day period, with different regions experiencing impacts at different times. Friday, January the 24th would mark the beginning as the Arctic blast reached Texas, with temperatures plunging through the morning. Cold rain would develop from Dallas to Little Rock by afternoon, then transition to a dangerous wintry mix of snow, sleet, and freezing rain by evening across the southern plains. Saturday, January the 25th, was identified as the most dangerous day for travel, with serious icing and heavy snow expected. The storm would reach the southeast across Tennessee, Mississippi, Alabama, Georgia, and the Carolinas. An ice storm would develop along a corridor from East Texas through southern Arkansas, while Atlanta, Charlotte, and Raleigh would begin experiencing ice accumulation by afternoon. Sunday, January 26th, would bring heavy snow to the mid-Atlantic, including Washington, D.C., Baltimore, and Philadelphia. Ice storms would continue in North Georgia and the Carolinas, while the storm began ending in the southern plains as frigid Arctic air moved in. The New York City area would begin seeing snow Sunday afternoon or evening. Monday, January 27th would see the storm wrap up by afternoon, with some early morning snow possible in southern New England. By this point, though, record cold would grip Texas and the South, with temperatures remaining below freezing and prolonging all impacts. This 4-day progression meant that different parts of the emergency response would be active simultaneously. As the storm was ending in Texas, it would be at its peak in the Carolinas. As the mid-Atlantic dug out, the South would be struggling with extended cold. The Geographic scope created a rolling crisis that would tax mutual aid agreements and resource sharing between states, because utility crews from unaffected regions who might normally assist with power restoration would themselves be dealing with the storm as it moved through their territories. This storm arrived during a particular moment in American weather and climate. The country was experiencing its driest period since 2012, with more than 2/3 of the nation facing drought. Weak La Nina conditions had been present since October 2025, contributing to this dry pattern. In one sense, the storm would provide some relief in the form of moisture that drought-stressed regions desperately needed. But as NOAA Climate Prediction Center meteorologist Brad Pugh noted, a lot of moisture is needed to ease the drought, given that precipitation shortfalls had exceeded 10 inches in several states since midsummer. One storm, even a serious one, would not solve the drought. The storm also arrived with several key uncertainties that forecasters openly acknowledged. The position of the line between snow and ice might shift, and a relatively small northward movement of the storm track would push ice into areas currently forecast for snow, changing the nature of the threat for potentially millions of people. East Coast intensification remained uncertain. Whether New York and Boston received serious snow or escaped with minor accumulations depended on how the storm behaved as it moved offshore. The exact storm track could shift 50 to 100 miles in either direction, and such a shift would dramatically alter impacts across the region. This potential shift made forecasting and planning especially difficult. The National Weather Service directly addressed this uncertainty, saying forecasters are confident the storm will be impactful and prolonged, but that specific details about exactly where the storm will hit and how much precipitation will fall may change. This uncertainty itself justified early emergency declarations. When you know something dangerous is coming, but you cannot be certain exactly where the worst impacts will fall, the responsible approach is to prepare broadly rather than wait for a level of certainty that may never arrive.